CS 3451 Introduction to Operating System. The topic is Process Scheduling, presented by Anuja R. APCSE, Rohini College of Engineering and Technology. Process Scheduling. The process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the selection of another process on the basis of a particular strategy. Process scheduling is an essential part of a multi-programming operating system. Such operating system allows more than one process to be loaded into the executable memory at a time, and the loaded process share the CPU using time multiplexing. Categories of scheduling. There are two categories of scheduling. One is non-preemptive, another one is preemptive. Non-preemptive, here the resource cannot be taken from the process until the process complete execution. Preemptive scheduling, here the operating system allocates the resources to a process for a fixed amount of time. During resource allocation, the process switches from running state to ready state or from waiting state to ready state. Schedulers. Schedulers are special system software which handle process scheduling in various ways. Their main task is to select the job to be submitted into the system and to decide which process to run. The schedulers are the three types. One is long-term scheduler, short-term scheduler, and medium-term scheduler. First one is long-term scheduler. It is also called a job scheduler. A long-term scheduler determines which programs are admitted to the system for processing. Short-term scheduler, it is also called a CPU scheduler. Its main objective is to increase system performance. Medium-term scheduler is a part of a swapping. It removes the process from the memory. It reduces the degree of multi-programming. Then operation on process. There are many operations that can be performed on process. Some of these are process creation, process preemption, then process blocking, and process termination. Process creation. Process need to be created in the system for different operations. One is user request for process creation, system initialization, execution of a process creation system call by a running process, and also using a batch job initialization. This is the diagrammatic representation of process creation using fork. It allows as follows. The process preemption is nothing but it makes sure that all process get some CPU time for execution. An interrupt mechanism is used in preemption that suspends the process executing currently, and the next process to execute is determined by the short-term scheduler. So this is a diagrammatic representation of process preemption: ready state, running state, and dispatch state. Then process blocking. The process is blocked if it is waiting for some event to occur. This event may be input and output as the input and output event or executed in the main memory and do not require the processor. After the event is complete, the process again goes to the ready state. The diagram that demonstrates process blocking is as follows. Here also the ready state, running state, and blocked state. Process termination. After the process has completed the execution of its last instruction, it is terminated. The resource held by a process are released after it is terminated. Then inter-process communication. The inter-process communication is the mechanism provided by the operating system that allows process to communicate with each other. This communication could involve a process letting another process know that some event has occurred or the transferring of data from one process to another. So this is the diagrammatic representation of inter-process communication. Thank you.